Hello and welcome everyone. My name is Mark Henry, a senior engineer with opMantic's North American office located in Charlotte, North Carolina. And today we're going to be talking about intelligent fault and configuration management for service providers and telcos. A bit of housekeeping before we get started. All the attendees will be on mute during the presentation. We just do that to cut down on feedback and background noise. We do want to have this as an interactive dialogue, not just a one-way conversation. So please feel free, if you have any questions during the presentation, use the GoToWebinar's chat panel, ask a question. We've got some monitors and moderators here who will be reading through them and then passing me little notes, and we can get those answered during the presentation. If you'd rather not go that route, we will have a Q&A session at the end of the presentation, and we've allowed lots of time for that. So if you'd rather wait until the end and ask your question, feel free. As a reminder for everyone, this session will be recorded and then made available to all attendees. And what we normally do is we stop the recording before we open the Q&A session. That way, for any of you who would rather not have your voices recorded, that's absolutely fine. So topics for today. We're going to talk about leveraging trending data to intelligently adjust fault management. And this is a really deep concept about moving, kind of maturing away from static thresholds and into more of a dynamically thresholded environment. We're going to talk about how to reduce event noise through effective consolidation, deduplication, prioritization, and storm management. Right, so that's the idea of taking that volume level on your events and taking it from an 11 down to somewhere that makes sense for you. For some companies, it's dialing it all the way down to a 2. For other ones, it's just dialing it down to an 8, 8.5, and then working through your event list and fixing events and addressing events rather than turning down the alarms themselves. Third thing we're going to cover today is we're going to talk about integrating and scaling configuration management. That's the concept of not just collecting configurations from your network devices, but also generating events from those configurations. So looking for changes in configurations and also pushing configurations back out to those devices. And finally, we're going to talk about automating event response. So this is the concept of actually applying some automation, some heuristics, and responding both with troubleshooting scripts and even with proactive action to help reduce the overhead on the engineering team. So that being said, let's get started with today's webinar. So taking a look at the IT service management maturity model, so the ITSM maturity model, and looking at what pieces we're really going to address today. And when you break out the ITSM maturity model, it kind of comes out into 5 different levels. Many companies that we deal with here are operating anywhere from level 0 to around level 2. And what we try to do is we really try to push people up into a high end of level 2 compliance or even into level 3. Level 4 takes a bit more work, but we really see a tremendous amount of benefit and value to the organization if you can start adding in things just simply as alert and event management, measuring your component availability and uptime, analyzing trends, setting your thresholds dynamically, and then measuring and reporting on service availability. If you can get up to that, measuring and reporting on service availability, how well your network and your systems are doing, you start doing predictive analysis on when components will fail, when you'll need to make investments in new equipment, new hardware, new circuits, bigger circuits, etc. But you have to get up into that measure and report service availability before you can start being a more proactive group for your organization. So let's talk about what it really takes when you're talking about intelligent fault and configuration management. So what are the goals that really drive decision making? And these are the standards that we walk into, that the opMantic Professional Services Group walks into every client with. The concept that we want to start by managing the measurement and thresholding intelligently. So we don't want to just collect on everything. We want to collect on things that make sense, that will be actionable, that engineers are actually going to respond to. We want to capture event details from all events and then conduct troubleshooting or remediation automatically. We want to assign priority based on client direction and then alert the correct resource in a timely manner. This process may seem obvious to you while you're seeing it here in print, but again, you might be surprised by how many very, very large, even enterprise level organizations, some good sized internet service providers and even telcos aren't following kind of a planned methodology for how they want to collect, alert to, and then respond to the events that happen across their network. And when we talk about network events, it's not just events from networking equipment, kind of the routers, switches, hubs, firewalls, load balancers. It's those, but it's also events generated from servers, from applications. It's creating synthetic transactions through your applications and alerting to those. It's monitoring availability and load time of websites, of web applications, etc., and then generating intelligent alerts to those types of things. So let's talk briefly about the solution that we're going to propose and that we're going to present as the solution to this problem. We're starting with Opmantic's free and open source NMIS platform. That's at the center of that big circle on the right hand side of your screen. So that is the core performance and fault monitoring package. It's handling all of your device polling. It's handled all of your inventory of devices themselves. It's figuring out what types of devices they are, determining what the base static thresholds would be on those devices. And then radiating out from that green circle, you have, like spokes on a wheel, you have commercial modules that plug into NMIS. One of those is opHA. opHA is our high availability module. What it does, it allows you to scale a single NMIS server into multiple NMIS servers. So you can scale horizontally for a layer of polling devices, and then you can expand vertically and add one or more master servers on top of that. We're also going to talk about opEvents, which is all about not just intelligent event response, but taking proactive action to events, and whether that's troubleshooting or some kind of a proactive response to restart services, restart servers, etc. And we're going to talk on about opTrend today as well, which is really about predictive trend analytics. It's the concept that you can take those static thresholds that NMIS applies and convert them from static into dynamic. So the system will actually understand what's normal operating procedure for the devices that are on your network. So just a quick kind of drawing on that concept. Again, if you're applying opHA to be able to scale your solution out, you can have 2 or more polling servers at that bottom horizontal level. You might place those out logically, one inside a DMZ, one outside your DMZ. You might have them geographically, one in your New York office, one in your San Diego office, one in your Jakarta office. And then you might put your master servers out in the cloud. So all of those pollers can handle their local responsibilities for polling, and then push that information back up to one or more master servers. A little more granular detail about how that looks from an individual server standpoint and what applications might be running on it. You'll see at the bottom of your screen, you actually have the devices that are being polled, the ones that are being monitored down here at the bottom, and then the different applications from Opmantic that are handling it and what services are being done. So for example, SNMP and WMI and service monitoring are all being done by NMIS, whereas opEvents is handling traps, syslogs, and also receiving a stream of events from NMIS for further application and processing. So let's start off with the concept of how we can leverage trending data to intelligently adjust fault management. So on the left side of your screen, we break down how NMIS, again, Opmantic's free and open source network monitoring solution, how it handles thresholding. So NMIS comes in, pre-built right out of the box. You don't have to configure anything. You don't have to look it up from your manufacturers or what industry standards are. NMIS comes pre-configured with 5 different threshold levels for every single parameter in our system that we collect, that our engineering team and that our clients have said, this is an important thing. We need to be alerted when it's outside of performance. We do 5 different levels. And actually, if you look at the list there, there's actually 6 if you include normal. So you'd have a normal state for a device. You'd have a warning, followed by a minor, a major, a critical, and then finally a fatal alarm. The nice thing with the NMIS solution is you can disable or you can pay attention to whichever of those levels make sense to you. You can change escalation policies based on the level. So, for example, a warning level might be, hey, I think I smell the popcorn burning. A minor might be, oh yeah, I can really feel it now. Major is there are flames in the microwave. Critical, the power's out in the building. And fatal, the entire house is on fire now. So you can determine at what level do you take action, who takes action, how are you going to tell them? Do you want to generate an email, SMS, text message, a pager, call, and notify people? Those thresholds can be rising or falling. So, for example, you might have an alarm for a rising temperature, but you might also have an alarm for a falling available memory. All of the events in NMIS are normalized across similar OIDs and manufacturers. So, for example, all alarms for proactive CPU utilization, no matter which OIDs are being collected, they're all pushed into one common event type. And the reason for that is just to make ease of management. All right, you don't want to have different types of manufacturers, different terminology. You want to follow one set of terminology. You want to understand what that event name means. And then you want to be able to, kind of from an engineering standpoint, be able to interpret and understand what that event's impact would be on that device. So again, NMIS's thresholding system, the system that generates the alarms themselves, are all static. They're all built into NMIS. It all comes out of the box. You can adjust them all. No problem at all there. In opTrend, we actually flip the model around right on its head. opTrend is all about gathering statistics and then generating a kind of a standard deviation map. Remember that bell curve you might have seen years ago? So what opTrend does is it collects up to 26 weeks of performance data. It compares day of the week in 1 hour windows. So it'll look at Monday from 9 to 10. It'll look at 26 weeks of Mondays from 9 to 10 and determine what is normal for each individual device, for each individual parameter that's being monitored. So it'll figure out, for example, what is normal for a specific interface on an individual device on Monday from 9 to 10. It'll figure out what is normal for that, what is the mean for that, for the performance of that CPU or that interface rather. It'll figure out what is average and what is mean, and it'll create a window between that. We'll show you that in a minute. We then use a SEDS algorithm to determine what is normal operation for that parameter on that device, on that hour, on that day of the week. And then what you can do is you can use opTrend to either enhance NMIS's static thresholding or replace it. So you can build up information in opTrend. You can actually enable it, have it running and generating events at the same time that NMIS is generating events from its static thresholding. And then if you're satisfied, you can actually turn off NMIS's static thresholding and have opTrend doing all of your performance trending and your thresholding. Let's see what that looks like. So to start off with the concept of threshold and alert turning, you have on the left-hand side, you have a breakdown of one of our models. This one just happens to be, looks like a Cisco device. We're capturing a bunch of OIDs here. You can see SNMP OIDs, Cisco memory, pool free, pool used, CIDR route number, stop top changes, etc., CPU total 1 minute revisions, etc. Over on the right-hand side, what we're doing is we're taking those events. We're taking one of those events, and we're looking at the proactive CPU event. We're looking at specifically average busy 5 minutes. right? So we're mapping that over. We're saying we're breaking this down, and this is an option. You don't have to have it, but we have different defined role types: core, distribution, edge, etc. You can define your own as well. And what this does for you is gives you the opportunity to define out again those 5 levels of thresholds. So in this case, you can see it goes warning for 30, minor 40, major 50, critical 60, and fatal 70. These are listed in alphabetical order rather than the numerical value. So again, just an example of how the built-in thresholding is done. Compare that to opTrend. On the left-hand side, you'll see that there is a breakdown of the opTrend billboard. So you'll see that there's a chart in here that gives you a listing of all the device parameters and how those devices are faring. Have they gone up or down in the billboard? It's just like very much like the billboard's top 40 on the radio. As devices and parameters move up and down, they'll, whichever one is top in that list. And you can see what we've done here is we've actually captured the top piece. We've clicked on view and seds, and then this has given us a breakdown. What opTrend will give you, I mentioned the concept of a mean. The green line here, that's the expected or mean value over the 26 weeks that it's been running. The black line is the actual current value, so what it looks like now. And then the upper and lower controls, marked by these blue lines, give you 3 standard deviations off of the mean. So again, it's all basic statistical analysis, but you can see that this moves up and down. And then anything that moves outside that point, so for example, you can see this liar. This one has gone outside, the black lines have gone outside the upper and lower mean. And the concept here, again, is to be able to go from a static threshold or a static alarm where you might say, gee, I want to set my temperature alarm at 90 degrees Fahrenheit. And anytime anything goes over 90 degrees, I want to see an alarm. But as we all know, none of us have ever seen a switch or a router stuck into an unair-conditioned closet. Someone's piled equipment on it, and that device always runs hot, no matter what. We can take everything off the top of it. Doesn't matter. That closet just doesn't have any airflow in it, and that device runs hot. And it always creates an alarm. When you have a static threshold, it's always going to create an alarm. You could adjust that threshold, but if it continues to be hot or get hotter over time, you're going to be sitting there and adjusting and nudging that threshold. Instead, what opTrend will do is determine what's normal for that device, for the parameters you want it to monitor, and then it will adjust your alarming based on what is normal for that device. So if that router sitting in the closet normally runs at 96 degrees Fahrenheit, you'll get a notification that it's running at 96, but it won't alarm until it gets outside of that control window, that upper or lower control window. And the nice thing here with opTrend is because you're getting both an upper and a lower control, it doesn't matter whether the number, whether the measured piece goes above or below that line, it'll still generate an alarm. All right, let's talk about reducing event noise. I had the opportunity to work with an internet service provider out in the U.S. Midwest earlier this year, and a concept that they kept bringing up to us is that in their current systems, and they actually had 4 different solutions in place in their organization. In their current solution, they had silenced so many alarms because they were spurious, they were incorrect. Nodes would go down just because there was high latency or there was a storm in an area for a brief amount of time, and an engineer would end up getting woken up at 2 o'clock in the morning. They'd check, and the problem would be cleared, or they'd suddenly have a power outage in a wide area, and they would get hundreds or even thousands of notifications flooding into their help desk system. These were all automated notifications, automated tickets being opened by, at their time, their existing network monitoring solutions. And so in order to get away from that, you have to be able to manage the way that events are not just monitored and created, but also how you escalate those events, how you determine who's going to be told about those things. And that all starts really with kind of understanding what your event processing is. And so we're taking a look here at the event processing flow in opEvents. opEvents starts by applying an archive list. It's literally a definition of all the events that need to be stored, that have to be held onto. Generally speaking, we store everything. There are a small handful of events that are already pre-populated in the archive list that are considered by the manufacturers as events that do not, they're useless, for want of a better term. It's all editable. You can change it all, so feel free. The next thing that opEvents does is it applies a blacklist. That's a list of events that should never be processed. So notice that blacklisting happens after archiving. So we will even archive an event which then is blacklisted and not acted upon. The third thing we do is then we apply a whitelist. And it's important to understand that the blacklist and the whitelist work together, not against each other. So if something is in the whitelist, which basically says you will always take action on this event, if it's also in the blacklist, the whitelist takes priority. We then correlate events into outages. The concept here is, again, to take a look at events that could happen regionally or within a network, within some kind of a logical connection, and rather than having individual events, pull them together into one. So for example, in the where you might have a regional power outage from a storm, rather than every device generating a node down event or an SNMP down event, instead the system will say, oh, there's been 5 or more outages within one geographic region. I'm now going to make that a location outage. And there are several ways of doing that. You can match on several different criteria, including things like company, owner, responsible party, location, SLA, VIP status. So lots of different opportunity there as well to be able to reduce the noise, right? Because once you correlate multiple events into one, it can also auto acknowledge those when they start to clear. And the nice thing is that you only generate one alert for the parent, the correlated event, rather than all the different notifications for the individual ones. The next thing the system can do is it deduplicates events. And what that means for you is it's actually going to look at all the events that are happening. So for example, if you have a node up, node down, node up, node down, node up, node down, it's now going to say, oh, that's really not multiple nodes up and down, node down. It's now a node flap. So it's going to deduplicate those types of events and pull those together. It'll determine the priority of the event based on a set of rules that are built into it, which are adjustable. It'll conduct any kind of actions. So are there any responses that have to be taken? And then it will actually start escalations at that point. So it'll say, oh, do I need to send an email anywhere? Do I need to connect through an API and push information? Do I need to send a copy of this event to a master server? Do I need to create a text message, or do I need a call, a pager? What do I need to do, and how do I need to do it? So the important pieces of this, almost all of Opmantic's products, in fact, I think all of our products, all of our settings are actually stored in configuration files. These are all plain text files. They're human readable. They're designed to be human readable. They're done that way so that it's fast to edit. Almost every type of configuration file has a GUI. So if you're more of a Windows type person, you like the GUI and you'd rather work through that, you can for about 80% of all the files that you might edit. The rest of them you just do with a text editor at the command line. We took this approach specifically because it makes replication of our system and pushing out changes across a large implementation very, very simple. You can even do it with opConfig. So you could create configuration files to manage the configuration of your own system and push it out across your network monitoring solution. But the whitelist, blacklist, and archive, those rules are all contained in event list rules.nmis. Correlation and suppression rules are all in event rules.nmis. And priority actions and escalations are in event actions.nmis. There is just to catch everyone up, there's a copy of today's presentation attached to the handouts panel of your GoToWebinar. If you're watching this after the GoToWebinar, you should be able to download a copy of this presentation in PDF format off of the opMantic site in the Learn section in our blog. So an example of some correlation rules that actually ship with our product now. So for example, the simplest one is in the top left. It's the location outage. It's the concept that we look at a list of various types of events, in this case, node down, service down, and SNMP down. Any combination of 5 of those from 5 different devices within a 60-second time frame will create a location outage. But they all have to be devices, those 5 devices all have to be assigned to the same location. The customer outage, same thing. 5 devices within 60 seconds, and they all have to be assigned to the same customer. A group outage, again, is 5 devices within 30 seconds assigned to the same grouping. And NMIS has multiple different types of metadata tags, including location, customer, group. There's about a dozen in all, and you can actually create your own metadata tags as well. And then we also actually have a correlation of a correlation. So a major disaster rather, is a network outage event, which has been 4 network outage events within 60 minutes. All right. In the top right, we also talk about suppression rules. We only ship really with 1 suppression rule built in. That's because generally speaking, we like to ship our systems noisy to begin with, but then make it easy to take that volume control from an 11 and tune it down to wherever you want to go. We start noisy and we recommend noisy because we actually teach in our training classes how to proactively go in and work on your network and fix the issues with your equipment that are causing the events rather than turn down the alarms, right? So we don't want you to take the battery out of the smoke detector above the stove because every time you cook spaghetti, you burn it and it sets the alarm off, right? Instead, what we want to do is we want to add an event that vents the heat and the smoke from the kitchen so that the alarm doesn't go off or only goes off when it's supposed to, and not spuriously. Next up, integrating and scaling configuration management. So there's a handful of challenges that kind of come around the idea of configuration management. I have the great opportunity actually to talk to about 30 customers a week here with opMantic. And it goes without saying really that every customer has their own concept of what configuration and compliance management is, what should or shouldn't be done. The position that opMantic has taken with opConfig is to make a very, very flexible system that can be managed and expanded by the customer, by yourself, following the instructions that are on our wiki. We ship with the ability to collect commands from command output from devices. So for example, we might connect to a Cisco router, execute a show running config, pull that back, compare it to the last version of that command, and see if something has changed. So we're going to do a diff on those. But beyond just doing a diff, we're going to do an intelligent diff. We're actually going to be able to ignore sections of that return information. So for example, date and time. Obviously the date and time between the 2 commands are going to be different. And you wouldn't want to necessarily alert on that change. So you can identify sections of the command that you want to ignore, and you can actually pick sections of the command that, were there to be changes, would generate an event. And that event would go from opConfig to NMIS, and then you could send it from NMIS to opEvents to take proactive action. The way it works, commands are run on a preset schedule. They're all done through a cron job. Generally speaking, they're broken up as daily and hourly. You can also add in commands to be executed just for troubleshooting. So you might run into a problem with a device, and you could say, opEvents could say, I want to run all of the troubleshooting commands that are applicable to this device. They can also be run on demand. So our event management system, opEvents, we mentioned that you can actually take proactive action. opEvents can actually reach out to a device, execute commands on it, whether that's collecting information or even pushing configuration out. So think about that concept for a moment. opConfig could collect your configuration settings. It might see a configuration change. So perhaps someone's taken a set password encryption and turned it off. So now the password for the device is stored in plain language. And they might have turned that off, and you want to make sure that that's actually set all the time. And so that gets picked up as an event. That change in the command gets picked up as an event, gets passed to NMIS, that gets passed to opEvents. opEvents says, oh, I can't allow this. I need to roll this device back to its last known setting. And opEvents can actually call opConfig and force the rollback of that device's configuration, and then wait and make sure that that configuration, that the old configuration retakes and that the device is working properly. So a lot of different things that can be done there to help control and kind of self-heal your network, right? So how long are we storing information in opConfig? So opConfig has a very flexible policy system. This is the default settings. All of these are completely configurable in the config for opConfig, so it's straightforward. But basically, it'll retain both the first and the most recent revision indefinitely. It'll retain any revision marked protected indefinitely, so you can actually go into a revision and say, I want to make sure that this doesn't get erased over time. So you can store a protected revision indefinitely. It'll retain the last n number of revisions. The default is 100. And 100 revisions in something is an awful lot, right? But it really depends on the command. So it'll store the last 100 revisions. And really, that's not a limit. That 100 default is not a limit of the system or the database or anything. It's just a number that we picked as a good starting point. So if you want to store the last 1,000 revisions, that's fine. You just have to have the storage room for it, and text actually doesn't take up much space in the MongoDB. The system is also set up to purge unprotected revisions older than 365 days, and it'll do that check every 24 hours. It'll just anything at the end of that 365-day period that doesn't follow any of the top 3 requirements just gets dropped off the end. So much like opEvents, opConfig kind of has its own collection alerting event process. So here's an example of how opConfig might respond to a piece. Starting from the left, NMIS detects a change. So NMIS might be monitoring a device, doing regular performance monitoring and collection, and something has happened. There's been a change in the BGP tables. There's been a change in performance of an interface. An event is created. That event is then passed on to opEvents. It sees that there's been a change that needs to be dealt with. opEvents then directs opConfig to collect whatever series of commands you want collected on that device. And opConfig is intelligent. It can figure out what commands work on which device based on the manufacturer, the model number, and even the operating system of the device. opConfig then would compare the results of that collection and then link that result to the event itself. Again, the concept here is to automate as much as you can, and not necessarily automate out the network engineer, but take the kind of mundane, everyday clicking that an engineer does to gather information to determine what to do, get that off their plate, right? So if the system can automate troubleshooting, information gathering, analysis, take some proactive action, document all of it, and then provide that information back to the engineer when the engineer finally looks at the ticket, then that gets them further down the road, right? It gets them further up that ITSM maturity model out of the 0 or 1 and up into 2 and even into the level 3. So regular collections, again, queued by a cron job, that might be the hourly or the daily collections. So the cron job runs, opConfig executes command collection against each device that is licensed in opConfig. opConfig will then compare the results of that collection against the last collection for that device. opConfig will then generate an event, pass an event to NMIS, and then that to opEvents. And then opConfig will link the results to that event. Again, that way you can go into opEvents, see that an event has happened, that there's been a change, and then be able to click on that and link back into opConfig to see exactly what's going on. So a common workflow when using opConfig with opEvents. So again, this is kind of a post discussion. The idea that there's been some kind of an event, understanding what the priority is, investigating it, understanding what the revisions and change control were, adding any comments or acknowledging the event, closing the event out, and then doing any kind of remediation actions after the event has been taken care of. So how are you responding through the cycle of things? And last but not least, we're going to touch on automating event response. So the first concept is how to determine what to do when an event actually occurs, right? We strongly recommend that you start with architecture criteria, the concept that you're going to look at all events that meet a certain set of criteria. That might be the type of device. Is it a Cisco device? Is it a Huawei device? What type of device is it? Who's the manufacturer? Or the criticality of the device. Is it an edge device? Is it a core device? And then apply whatever actions you want to, regardless of the event priority. So even if it's a low priority event, you should apply those event actions anyway. Collect data and store the data, because from an analytics standpoint, if you're storing the data, you can make good decisions from it in the future. You can actually drive better decision making. You can also get a better viewpoint on what's happening across your network. Event actions are always handled by polling servers. So if you have a high availability layout, so you've got a horizontal level of servers defined as polling servers that are out there actually communicating, gathering information using SNMP, processing SNMP traps, parsing out syslogs, etc. All that should happen at the polling server level, never at the master server. The results of those events, event actions rather, would be stored with the event itself. That way, when the engineer comes back and looks at the event, they can see what event actions were run, what data was gathered, how well that's working. Again, event actions can be troubleshooting or remediative in nature. We ship with a good pile of troubleshooting pieces built in. We'll take a look at those in a minute. Remediative basically are ones that, generally speaking, will work with our clients, help them understand and process out the things that their engineers normally do. So I use this example a lot. We have a client here writes a lot of their own video editing software, and unfortunately has a bit of a memory leak in it. And so internally, what would happen is a user would have problems using the software. They'd call into the help desk, a ticket would be created, it would be passed to an engineer. Eventually, someone would look into the problem. They'd remote into the server, see that the service is running high on memory usage, and they'd restart the service. They'd wait a few minutes. If that didn't clear the problem, they'd reboot the server itself. And so what we did is we just sat down with their engineering team and we said, look, give us a list of all of the tickets that you deal with over the past month. And they gave us a long Excel list. We sorted the list until we were able to group it into which events were happening most often. And then we sat down with them and we said, what are you doing here with this server? You get a lot of people who complain about this application. What do you do? And then we just flow charted out on a whiteboard what the steps were that the engineers took. And then we replicated that in a small script in the event actions file that did exactly what the engineers did. And so even before a user can pick up a phone and call that help desk person and report the problem, our solution is now live monitoring the memory usage of that server, saying, oh, if you go above 75%, that's bad, and we want to restart the service. The system still logs the event. It still keeps track of if the service is restarted and the memory isn't freed up to escalate the problem somewhere else, and it still generates a help desk ticket for them. But what it's doing is it's saving time on the help desk, so someone doesn't have to call in and log a problem. It's saving time with an engineer. Someone's still going to get a ticket and have to look into it, but they don't have to remote in. They don't have to make an evaluation. They don't have to restart the service. It's just being done in the background. So let's take a look at a few of the shipping actions. You can see in the left-hand column, it's an example of specifically troubleshooting actions designed for Cisco devices. So this is actually executing a series of CLI commands using opConfig. So again, this is opEvents interacting with opConfig to gather CLI information and then attach it to a ticket. So an example of pieces here, you've got proactive CPU, show process of CPU sorted, show IP flow top talkers. You've got several different pieces here. And again, this is in response. The event is actually in bold. So for example, you might have here role type core and event equals interface down, and then it executes show IP flow top talkers. And then for role type distribution and stateful equals BGP neighbor, ping the node host, ping the event element. So it's pinging the local device as well as the kind of its neighbor, and then show IP BGP, IP BGP summary, and IP route summary. Down the middle, you'll see examples of troubleshooting for Linux type devices. So our system knows, who the manufacturer of the devices are, what types of devices are, what the operating system is. And so in these examples, it'll actually connect to the device and it'll execute these commands on that device. Then you have an example of some kind of basic generic troubleshooting down the right-hand side. So for example, in response to a node down, it'll ping the node host, it'll run a trace route, and then it'll run an MTR. And again, the results of all those commands will be attached to the ticket, so the engineer can see it in plain language. They'll see the results just like if they had typed it into the terminal window themselves. Then for SNMP down, run a ping. For service down, run a ping as well. And then for an outage, either a location, customer group, etc., it'll ping the node, and then it'll run a trace route, and then an MTR. So it'll act just very much like a node down. All right, folks. That concludes our overview today of opMantic's fault and configuration management solutions for large-scale providers. What I'm going to do now is I'm going to turn off recording and open the